Today I'm Fernando Manalo from ECE4 and today's experiment is for the IoT laboratory TECET414LA and we are gonna perform experiment number 4. Now I will start the experiment. To start the experiment, I will open the PKE file. There are some outdated devices. Do you want to update them? No. It should be fine. And here is the activity. And as we're using an old version of Cisco Packet Tracer, we can dock it. Now, the objective of this experiment is to explore the smart home, analyze the usage of fog computing in smart home. In this activity, I will explore the smart home example. Depending on the application, some data is best processed close to the source. The smart home example takes advantage of fog computing to monitor and act upon the levels of smoke detected in the room. For the part 1, understanding the devices that comprise the smart home. Commonly, ISPs deliver data and video over a single coaxial cable. Starting from the attic, so here, a coaxial splitter is used to separate the video signal from the data signal. Two coaxial cables leaves the splitter in the topology. Which device does the coaxial cable connect to? Now, as you can see, two cables comes out from the coaxial splitter and it connects to the cable modem and the TV. For letter B, the cable modem is the interface between the ISP's network and the home's network. To which devices does the cable modem connect to? The cable modem is connected to the home gateway. And the home gateway acts as this one, concentrator and router to all internal home devices. It also provides a web-based interface that allows users to monitor and control various smart home devices. Notice that the home devices can connect to the home gateway through either wireless or wired connection. And in order to do this, we have to see this note. Packet Tracer uses dash beam to represent wireless connection, but it can make it hard to read when there are too many present. In order to turn this on, we go to Options, Preferences, Hide tab, and then uncheck the wireless. And now we can see all the wireless connections. Now, list all the devices connected to the home gateway. We have to list all the devices, all these black lines. So, first is the smart window, the smoke detector, the temperature meter, this one. The smart fan is also connected. The tablet is also connected. The smartphone is also connected. The smart alarm is also connected. The smart water meter, the smart sprinkler, the smart coffee maker, the smart door, the garage door is also connected, and the smart lamp. And now, the next part of the experiment is interacting with the smart home. The devices in the smart home can be monitored and controlled remotely through any computer in the home. Because all smart devices connected to the home gateway, which is also a server web interface, tablets, smartphones, laptops, or desktops, and computers can be used to interact with the smart devices. Now we will click the tablet. And then we'll navigate to desktop and web browser. We'll add the 192.168.25.1, and we are in the home gateway. Now we will enter admin as username and admin as password, and it displays the IoT server devices, and it also shows that the devices or the smart devices that we can control, and it also shows their statuses if you open it. The next step is the smart door is currently unlocked, represented by a green light. We will go to here. This is the smart door. But it can be locked remotely. Click the smart door in the browser to expand the option. We will go to the smart door. Here's the smart door, and but it can be locked remotely. So we will lock it. And as you can see, it turned red, so it is locked. Click lock to lock the door. Was the door locked? Yes, it is. It is locked, as we can see. If we use Alt, we can open it. I'm using Alt and I can open it. Unlike let's say the window, I can open it, but the door I can't open. And then the next step is to click unlock to unlock the door. Now the door is unlocked. Click the smoke detector in the browser to the expanded section. Smoke detector. What is the smoke level reading provided by the smoke? The smoke reading right now is level 0. Can the smoke detector be controlled? Here, there are no interface, so it cannot be controlled. Smart devices can also be controlled directly, representing physical interaction within the logical. That's you can do it with the coffee maker. Turn on, turn off using the Alt key. Fog computing in smart home. The MCU added to the smart home is used to monitor the smoke levels, prepare the smoke sensor, and decide if the house should be ventilated. If the carbon monoxide raises above 10.3 units, the MCU is programmed to automatically open the window, front door, garage door, and start the fan in high speed. This action is only reverted. Close doors and windows stop the fan when the carbon monoxide levels drop below 1 unit. And the step 1 is to run the classic car. In order to do that, the owner keeps a classic car, so the classic car generates carbon monoxide. First, we will go to the tablet, which we're already here, and then take smoke detector, and then start the car engine. I will start the car engine. But before, we should note that the window, the fan is not moving, the doors are closed. We will start the engine. What happens to the air inside the house while the car is running? The air is now at it turns to high level, or rather the smoke level increased. And then what happens to the air inside after after it opened? As you can see, the window, the fan is on, the doors are open. After it opened, the smoke levels drop to 1.637. What happens to the air? What's the next? While still monitoring the level, stop the classic car. Wait, this one first. Does the MCU close the window, no, the MCU does not close as it still can detect at 1.6 and it needs to be lower than 1. Now, I will turn off the car. What what happens to the air quality inside the house? The air quality turned back to 0. What happens to the doors, windows, and fan? They all closed and the fan turned off. And reflection. This example shows that the decision between cloud and fog processing depends on the application. In the smart home example, fog computing was the best option. In smart home example, the data generated by the smoke sensors were processed and used to make decisions regarding the house's air quality. In this scenario, there was no need to send out sensor data to the cloud for processing. Cloud processing would slow down the response time, potentially putting lives in danger. Another possible problem relates to the internet link. If the connection to the internet was lost, the entire system would fail. Now, what we can learn in this activity is that in this case wherein an immediate decision needs to be computed, fog processing is better, or rather fog computing. Because if we use the cloud, the delay would be significant and it's not wise to use cloud in this kind of scenario. And that is the end of this experiment. We'll check the results. And that is the end of today's experiment. And we have successfully achieved our objective, which is to explore the smart home example and analyze the usage of fog computing in the smart home. In this case, it uses the MCU. And that's the end of today's experiment. And thank you.